Okay, we're on. This is lesson 4, the first topic in grade 12 essentials, precision and measurement units. So we just watched a little video, there's a link to it on the blog, where we learned the difference between accuracy and precision. Two words that people in everyday life mix up all the time. We saw this last chapter with people who think odds and probability are the same thing. What's the probability something happens? What's the odds something happens? Feels like you're talking about the same thing, but they're mathematically a little bit different. Same thing here. How precise you are and how accurate you are a little bit different. Here's the best definitions right here. Accuracy is how, that's supposed to be an H, let me try that again here. How close a measured value is to its actual value. And precision is the exactness of a measurement. Precision is the measure of variability, or the opposite of variability maybe, repeatability. I honestly don't know if repeatability is a word, but sure. Sounds like a word, so we'll use it. How repeatable something is. If it's very, very highly repeatable that you get the same measurement over and over again, you've achieved a high level of precision. But does that mean you're accurate? Oh, not necessarily. Because accuracy depends on how close you are to the number you're supposed to get when you measure.
Did you run away?
Yep. Thank you very much. Okay, so giving people a second to catch up on the little notes here, I'll just mention that this unit's very short. We'll do a lesson today, lesson tomorrow, lesson Friday, and then it's basically done. And then we can spend a couple days working on some review and stuff for it. We'll do a little quick mini test on it, and that gives us then a few days next week to start doing some exam review. So I already gave you guys a little booklet. Hopefully you have it. If there's people who don't have it because they weren't here that day, let me know. But there is a booklet of some old exams that we can look at. Okay, back to this. Everybody caught up to the words? So in the little video we watched, they used an archer. If an archer is highly accurate and highly precise, that means he will hit the bullseye repeatedly. What if he's low in accuracy but high in precision? Or sorry, other way around, sorry. He's low in precision but high in accuracy. So he's high in accuracy but low in precision. Well, that means he'll be around the bullseye. He might hit it once in a while, but he's not consistently hitting the bullseye because he's not very accurate. Okay? Or he's not very precise. He's accurate, he's around where he's supposed to be, but he's not consistently getting the same thing over and over again. What if you had low accuracy but high precision? Well, that would mean that you're hitting the same spot over and over again, but it's not the right spot. And of course, if you have low accuracy and low precision, well, that looks like you maybe closed your eyes and just kind of shot 4 times, and you weren't even close. It was like randomness. It's not accurate. It's not precise. It's not the same number over and over again, and it's not close to the number you're supposed to get. So that little diagram, I think, is very helpful to make sure that you understand the basics. But now we'll switch over to our notes package. I'll just pause the video here for a quick second. Oh, we don't have a pause on here. Interesting. don't know why we don't have a pause on here. Last time I used this, it had a pause button. Okay, never mind. We'll just have a little downtime in the video here while I hand out to the people who don't have this booklet yet the booklet. So stay tuned, guys, watching the video. There'll be a little bit of dead time here. All right, so who doesn't have this booklet? You got this? You've got it. Cyrus, you have it. You got them right there. I'll get the other one. Okay. So let's go to the first lesson. Okay, so in our booklet Precision Measurement, we're going to take a look at the first lesson here, and it's more of the same. It's accuracy versus precision. So determine if each quantity below is an exact value or a measurement. Paul's height is 175 centimeters. Well, that's definitely a measurement. The gasket has 8 bolt holes along its edges. Well, that's an exact number. Counting is not the same as measuring. You can count something exactly. The diameter of a bolt is 3/8 of an inch. That would be a measurement. It's possible that you look at 2 different bolts and you have one that's slightly bigger than the other, even though they're supposed to be exactly the same size. And it's that kind of variability that you want to see, well, what's the most amount of variability that we'll tolerate in this situation? We'll talk a lot more about that as this chapter goes on. There are 1,000 grams in a kilogram. That's not something you've measured. That is a fact. So that is an exact value. Like we just talked about, accuracy is how close a measured value is to the exact value. For example, when measuring out 1 cup of sugar for a cake, what assumptions do you make about the accuracy of the measurement? I would say, well, I assume that this little measuring cup that says that it's 1 cup of sugar is in fact exactly, or at least close to exactly 1 cup of sugar. So you assume that the measuring tools you are using give you the values that they're supposed to. A measurement can be inaccurate if you don't use a measuring device correctly. The number of people I have seen who grab a ruler and they go to measure something and they put the start of where they're measuring on 1 instead of 0. Have you ever seen people do that? Hopefully by high school people aren't doing that anymore, but when I taught junior high, I'd see kids do that all the time. And I'd say, why are you doing that? Why aren't you starting at 0? And it's like, well, I actually kind of know the answer to that question. It's because you count by starting at 1. 1, 2, 3, 4. So I'm going to take my ruler and start it at 1. No, you start measuring at 0. So that's a common error. You're not using your device correctly if you're doing stuff like that. The other problem, of course, is you can have a measuring device that is defective or inaccurate. There can be, of course, degrees of accuracy. A low degree of accuracy means the value is not very near the actual value you're supposed to get. A high degree of accuracy means that the value is very near the actual value. Okay? So that's accuracy. Precision is, again, mathematically speaking, it's about repeatability. It's about how you can get the same value. If I use the same ruler that you use, we should have a precision. We should get the same measurement, you and I. And how well we measure, how precise we are, is we look at what the smallest unit available on the measuring device is. 1 cup measuring device is usually precise to 1 cup. For those of you who don't know what I'm talking about, if you're doing cooking and you just get one of those little, the ones in my kitchen are red, and it says right on the handle, 1 cup. It usually doesn't have any markings inside of it. You just are supposed to know that when you fill it to the top, that's a cup. Right? If you wanted a half a cup, you go grab the smaller one, where the handle actually says a half a cup on it. Right? You don't take the big one and say, well, it's about the middle there, I don't know. You're not supposed to do that. That would be not very precise, because there's no marking on it that tells you where halfway is, at least on the set that I have, because there's another different cup for half a cup. And then there's another smaller one for a third cup. And they all sit inside each other. You know, like those little Ukrainian Easter eggs. You take out a smaller one, then a bigger one, then a bigger one. Okay? Now, how about a meter stick? If we're looking at a meter stick, what's the precision? What's the smallest thing you can read off of a meter stick? Well, the answer to that is, meter sticks are broken up into centimeters, and then between the centimeters there's 10 little lines, and those are millimeters. So a meter stick is precise to 1 millimeter. A bathroom scale that you stand on measures half of a kilogram usually, right? It'll say kilograms, and there'll be a line between the 2 kilograms. So it might look like this. It might say, 5, tick, 6, tick, 7. So if the needle ends up there, you're between 5 and 6 kilograms, right? But are you 5.5? Are you 5.6? Well, you don't know. You just know that you're around 5.5. So your precision is a half of a kilogram. Now, what about old-fashioned rulers? Now, anybody here who's done woodworking or you've been in shops classes, yes, we are a metric country. We're supposed to use the metric system when we measure stuff, but because our biggest trading partner is the country to the south, which is the last first world country for sure in the world that does not use the metric system very much, because our industry is so tied to theirs, there are some things that we never really changed. We were supposed to change everything to metrics back in the 70s, but there's some industries and there's some walks of life where we still use the old system. One of those tends to be woodworking and carpentry. Most people who are working with building things out of wood, they're framing houses even, they're still measuring things in the old imperial system that the Americans still use. It's called the imperial system because it was pretty much the common system throughout the Commonwealth countries, where, we had the, King George, Queen Victoria, all that. Even England abandoned that system, and it's their system. And they are a metric country when they measure stuff, for the most part. But the Americans stayed with it. So we still have to deal with feet and inches. If you're using a ruler, and it's not metric, it's not in centimeters and millimeters, what's the smallest thing on most rulers or on most tape measures? You know what I mean by a tape measure? I usually have one here. Yeah, here we go. What's usually the smallest thing you can measure on a tape measure? Just taking out a tape measure, those of you watching the video. It's usually 1/16 of an inch. So that says 1/16 of an inch. The 2 little apostrophes means inches. So while I would, and I think most of the world who is not American would agree with me, would find the metric system far superior to the old imperial system, as a math person, there's one thing I did like about the imperial system. It forced people to be good at counting in fractions. So it made the job of teaching junior high fractions a little easier because people had seen fractions before. They'd measured stuff. They knew what a half of an inch was. They knew that if you wanted to be between a half of an inch and an inch, you wanted 3/4 of an inch, or 5/8 of an inch, or 9/16 of an inch. Those were common things to people who had measured stuff. So when your kids walked into junior high fractions, they'd seen those numbers before. They'd worked with them. Those days, sadly, are pretty much gone. All right, moving on. And when you actually have a measurement written down, the precision of a number refers to the place value of its last digit. So if I tell you that I have a measurement that's 3.45 centimeters, the precision of that is 0.01 centimeters. Get it? This is the place, that 5, where I am the most precise with that measurement. If I had 867.2 kilograms, my precision is 0.01 of a kilogram. If I tell you that I've measured something and it's 3.5 inches, my precision is a half an inch. Or, if you like the little apostrophes, half an inch. When it comes to precision, like accuracy, can be measured and compared in how precise you are. What degree of precision do you have? If you have a low degree of precision, that means there's a large uncertainty in your measurements. If you have a high degree of precision, then there's a very small uncertainty in your measurements. Like they mentioned in the last video, when it comes to engineering and designing precise things, like a good example would be car engines, the pistons in a car engine have to be designed and built to within far smaller than a 1/16 of an inch. If the piston was off by a 1/16 of an inch, it would be grinding against the piston shaft every time the engine took a stroke, and eventually it would blow up. So things that need to be highly precise have to have very, very precise units of measurement. Anyway, that's the first lesson. We'll move on to spending some time going through the first assignments, which is in this booklet right here, which we'll just drop to the beginning of it right there. And I think the first 8 questions are basically this assignment for this lesson. So 1 to 8 in this booklet is the first assignment, and we'll give people some time in class to work on that right now.